Hey, what's up, guys? Hey, another day, March 17th, 2021, and I've got for you another coding challenge. This one is called uh, minimum add to make parentheses valid. Problem 921 on LeetCode. So, this is a classic problem, and I'm sure if you've interviewed at different places, you've probably seen it as an interview prep problem for classes. It's often taught, and it's often used as an example on basic data structures. So it's pretty straightforward, and it's a pretty straightforward problem. And it's basically asking you to take a string and the string is composed of parentheses, different, you know, parentheses mathematical in a mathematical notation form, and given any string of parentheses, which are open and closed parentheses, that's all it contains. How many parentheses do you have to add to the expression in order to the make the expression valid? So, for example, we'll go through these examples and show you what that means. So, because I think, the name of the title kind of gives it away, but it's also a little unclear. And it would have been nice if they showed you what the valid parentheses string is. So the thing is, let's say if we take this guy, example 1, what's the minimum number of parentheses you need to make this valid? So basically, that's that, right? So you need 1. If you have 3 open parens, how do you make this valid? Well, the computer just did it for me, but either way you add 3 more, so you need at minimum 3. Okay, you can have more than that, right? Here's an example. If I have the original 3, then I add another 3 more, and then I can add, like, inside of 9. So that's a way to make it valid, but that's not the minimum way. And here's another problem. That's just you don't need any parentheses because it's already valid, so the minimum is 0. And then you have this guy here. I think 1, 2, 3, 1, 2. So how do you make that valid? So well, you're going to have to add 2 to the outside and 2 to the outside like that. Okay, to the right side. So if you think about it, this seems at first like a little bit of a complex problem. Okay, because you're like, well, how am I supposed to find the minimum? Is there like an optimization? Is this some sort of like dynamic programming if you want to go that crazy, or do I have to find like do a depth first search in all the parentheses present? I mean, your mind can probably go in all kinds of directions, but this is essentially a problem which follows the greedy property in the sense that um, there is there is a solution, and the optimal solution is basically the solution of local optimality, which means attempting at every step to make the parentheses string valid every iteration. So, what does that mean? What do we do? How do we iterate through this string and know when to where to add that parenthesis, an additional parenthesis, or an additional parenthesis, or multiple parentheses in the string to make the string valid? Well, so the first thing that should come to mind, if you have some background in computer science, is that when you see validity of string expressions, especially you should think expression trees, and you should think, well, okay, maybe I need to use some sort of stack structure. Think expression, string expression, think stack. Usually that's the case. But the reason why also is because the stack data structure is the easiest way to keep this string up to date, so to speak, as you get new input, right? So you can treat this as a streaming input problem, right? And as you get new input, you continuously validate the string, or continuously figure out how to make the string valid. Okay, and whether that means adding a closing parentheses, or even ignoring the parentheses and knowing that at some point in the future you're going to have to add more parentheses, and by the time you get to the end, you just know that you need to add as many parentheses as have been left on the stack. Okay, so it'll be a little more clear when I code it, but that's the basic strategy, right? We're looking to see how big the stack is at the end of the iteration. And remember, we're trying to validate this string in a streaming way as we iterate through the string. Okay, so first, as I said, enough talking, here's some coding. First, we want a stack. Okay. So a stack is a LIFO data structure, last in, first out, equals new stack character. Okay. So we have our stack, and now we want to iterate to our string. So because we want to obtain all the characters. Okay, so first thing, what we do is that if this, we want to start adding to the stack, right? So if the stack, but how do we know to add to the stack or not? So first thing I want to do, I'm going to like do this in reverse and explain it. So first thing I want to do is actually try to validate the string. So I'm going to look at the top of the stack. If not, stack is empty, and stack.peak equals. So if this top of the stack is equal to the open parentheses, right? Then we want to check if, and let's for brevity, car C equals at I, so we're getting the character. If C equals close parentheses, then stack.pop. Pop. Okay, what am I saying here? I'm saying that if we have a close parenthesis, if we have an open parentheses, if the top of the stack is let's see, is that the right? If the top of the stack is a closed parentheses, and the next parenthesis, open parentheses, and the next parenthesis specified by C, the character C, which is the character at the index I of the string, is the closed parentheses, then we don't want to consider this as part of the validation anymore, these two pairs, because it's already valid at that point, right? Else, that's the immediate way. Else, if that's not the case, stack dot push. Let's see. So if that's not the case, meaning if we have another open parentheses, we're going to keep adding those, right? And every time we add another open parentheses, it's yet another closed parentheses. We'll eventually have to add in some time in the future, whether it's the next iteration or a subsequent iteration, to close to validate that string. Okay, so it would be like if we look like we add open. I hate this autocomplete here, but you get the idea, right? If you add open, then you have to add close before the string parentheses becomes invalid. So else, or valid. So else, now if the stack is empty, right? That's going to be, or if the next condition, if the parentheses at the top of the stack is a closed parentheses, then we just push the parentheses over there. So we repeat this condition. Okay. So at the end of the day, so we'll just, because then that'll be something like, well, we have this already, so it doesn't matter what we do, right? If we add another open parentheses, a closed parentheses, that'll invalidate it. But if we keep adding closed parentheses, then whatever we do, we're going to just keep adding to the stack. And the only way to validate it is to put the characters, the opening parentheses in the front, which we'll never do in this iteration. We're just trying to find out what the stack.size is. Okay? Stack.size will, the final length of the stack, the final height of the depth of the stack, whatever, will determine how many parentheses are needed by someone else who is running some other program and sees our output to validate the string. So let's run that. There you go. Test case worked. Let's throw another little test case in here. There you go. And when I get 2 test cases working, I usually feel good about all of them. So, yep, so that's pretty good. That works. Now, it's faster than 53% of all programs, and it's using 45% of the memory. So, of the highest ranking program. I think that's probably because some people don't use stacks. You don't have to use a stack. It's just convenient standard structure to use. So that's it. My quick problem of the day. Like, subscribe, do all that good stuff to get me some fame or whatever. Or even if you like my videos or if you don't find that they're helpful, yeah, then just do your thing. I'll see you later. Have a good night.